Japan was the first in the world to invent the latest railgun, military technologies of the future. The idea of using electromagnetic energy to accelerate projectiles to hypersonic speeds has occupied the minds of engineers and military designers for more than 100 years. The principle of the railgun was theoretically described at the beginning of the 20th century, and the first experimental installations appeared in the 1920s. The essence of the technology is simple. Two parallel conductive rails create a powerful magnetic field, and an electric current passing through a movable armature generates an ampere force which pushes the projectile out of the barrel with tremendous acceleration. No gunpowder, no chemical propellant charges, just electricity and physics. But neither Americans nor Europeans have been able to overcome engineering problems for decades. Japan, apparently, has managed to advance the furthest. The Japanese Ministry of Defense began preliminary research in the field of electromagnetic mass acceleration systems back in the early 2010s, but a full-scale development program was launched in fiscal year 2016. The project was officially named Electromagnetic Acceleration Systems Research and was implemented by the Ground Systems Research Center, part of the Agency for Technology, Procurement, and Logistics, ATLA, responsible for advanced development, arms procurement, and technical support for the self-defense forces. Japan Steel Works, one of the leading Japanese manufacturers of artillery barrels and weapons components for the Navy, became the main industrial partner of the project. The research program was designed for the period from fiscal year 2016 to 2022, and about 1 billion yen, approximately $7 to $8 million at the current exchange rate, was allocated for its implementation. At an early stage of work, the designers faced the main problem of all railguns: catastrophic barrel wear. When huge currents pass through the rails and fittings of the projectile, a huge amount of heat is released, and the mechanical contact between the movable armature and the guides leads to rapid erosion of the material. This was the problem that ruined the American program. The prototype of the US Navy failed after several dozen shots, which made the weapon unsuitable for real combat use. Japanese engineers followed the path of consistent selection of materials. Initially, the rails were made of copper, but during the experiments, the copper guides were replaced with a combined alloy of several metals and other materials, the exact composition of which was not disclosed. The result exceeded expectations. Even after 120 shots, no significant damage was found on the rails. For comparison, the American prototype began to collapse after less than 30 shots, and by 2021, the Pentagon had officially curtailed both its land and sea programs, spending a total of over $500 million on development. In 2018, the Japanese Ministry of Defense released a video showing a prototype of a 40mm electromagnetic rail cannon along with related test equipment. The prototype demonstrated the ability to accelerate a steel projectile weighing about 320 grams to a speed of 2,297 meters per second, which corresponds to the Mach 6.5 number. These indicators confirmed the viability of the selected design solutions and opened the way to the next stage, sea trials. A historic event took place in October 2023 when ATLA announced the world's first shipboard test of a railgun. The shooting was conducted from an offshore platform with the assistance of the Japan Maritime Self-Defense Forces. A video posted by ATLA on the social network X captured the moment of the shot and the flight of the projectile over the water surface. At that time, no other country in the world had conducted such tests from aboard a ship, which allowed Japan to declare a global priority in this area. The agency stressed that it considers the railgun as a means of protecting ships from air and surface threats using high-speed projectiles and intends to accelerate the introduction of this technology into combat practice. In April 2025, the Maritime Self-Defense Forces released photographs in which the prototype railgun was first shown mounted in a distinctive angular tower on the deck of the JS Asuka test ship. This ship, operating under the control of the Naval Research and Development Command, has long served as a floating laboratory for testing advanced weapon systems. The photos were taken on April 9th during a visit on board by the commander of the self-defense fleet, Vice Admiral Katsushi Omachi, who arrived to inspect the progress of the work. The weight of the prototype, according to ATLA, is about 8 tons, and the barrel is 6 meters long. The next stage became even more significant. From June to early July 2025, ATLA conducted full-scale naval firing directly from the JS Asuka. During these tests, the railgun hit a target ship for the first time in history. On September 10, 2025, ATLA published photographs and videos of the shooting, as well as the first images of damage to the target vessel. The agency reported that the tests provided valuable data on the integration of the railgun with shipboard systems, on the accuracy of firing, and on the operational characteristics of weapons in real sea conditions. According to the updated data, the barrel life was increased to more than 200 rounds while maintaining the projectile velocity of about 2,300 meters per second. The current characteristics of the prototype are as follows: caliber 40 millimeters, projectile mass about 320 grams, muzzle velocity about 2230 to 2300 meters per second, max 6.5, charge energy 5 megajoules. However, the long-term plans are much more ambitious. The developers intend to increase energy to 20 megajoules and speed to Mach 7. With such energy, a projectile, even one that does not carry explosives, is capable of piercing the hull of a warship and disabling critical compartments with the pure kinetic energy of the impact. The cost of the entire development program has not been officially disclosed, but individual figures have nevertheless become public. The initial stage of research from 2016 to 2022 cost about 1 billion yen. In the defense budget for fiscal year 2024, Japan allocated $167.1 million for further work on the railgun, defining the task as creating a weapon capable of hitting various aerial targets with high-speed projectiles. One of the main economic advantages of a railgun is the cost of ammunition. The projectile is essentially a piece of metal without explosives, sophisticated guidance electronics, and a rocket engine. According to various estimates, the cost of one shot can range from $1,000 to $25,000, depending on the caliber and configuration. For comparison, the SM-6 anti-aircraft guided missile, which forms the basis of the naval air defense of the fleets of Japan and the United States, costs about several $1,000,000 per unit, while the SM-3 interceptor missile for atmospheric interception of ballistic targets costs almost $28 million. In February 2025, Tokyo purchased 150 SM-6 missiles from Washington for $900 million, but even this stock may not be enough in the event of a massive missile attack. Japanese Kongo, Atago, and Maya-class destroyers, equipped with the Aegis system, carry from 90 to 96 vertical launcher cells, and this ammunition can be depleted in a matter of minutes when repelling a combined strike by hypersonic, cruise, and ballistic missiles, complemented by kamikaze drones. It is the threat from Chinese hypersonic warheads and long-range cruise missiles capable of reaching Japanese territory that is the main incentive for the Japanese program. China is actively building up its arsenal of DF-17 hypersonic gliding warheads and long-range cruise missiles capable of reaching Japanese territory. The unpredictable trajectories and low altitudes of these weapons create a serious burden on Japan's existing two-tier missile defense. The railgun could fill a critical gap in the defense at the transatmospheric and terminal interception sites, providing an almost unlimited supply and the ability to conduct continuous fire without the risk of accidental detonation of ammunition on board. In addition to air and missile defense, ATLA is considering other combat options. The agency's conceptual schemes demonstrate railguns mounted on cargo platforms as mobile coastal artillery systems. These installations could create access exclusion zones along the southwestern islands of Japan, threatening Chinese surface ships, amphibious forces, and support vessels. Ammunition of various configurations is also being developed. Armor-piercing shells for hitting point targets, and fragmentation shells that explode in the air to disperse hundreds of metal balls over a wide area. International cooperation gives the project an additional impetus. In May 2024, Japan and the Franco-German St. Louis Research Institute signed a framework agreement on joint research in the field of railgun technology. European interest in these weapons is dictated by common defense needs in the face of growing missile threats. In addition, ATLA continues to exchange technical information with the United States despite the fact that the Americans have formally curtailed their own program. Kazumi Ito, head of ATLA's Arms Policy Department, publicly acknowledged that the project still faces serious difficulties. The main ones are the miniaturization of energy systems, which at the moment are comparable in size to sea containers, the improvement of cooling systems, and further increase the survivability of the barrel. The reload time between shots and the rate of fire have not yet reached the level necessary to reliably intercept high-speed targets. What do you think about this?